Our tutorial today will be about decision making in Python. We will see 7 problems, simple, intermediate, and a bit advanced. No loops in the examples we solve today. Loops will be done in problem solving session number 3. Let's see the first question, equality check. The user inputs three numbers, and you should tell him if are they all equal, or only 2 are equal, or none of them is equal to any other number. If you see the sample run here, enter 3 integers A, B, C, 10, 45, 10, then you get the output, 2 values are equal. In the second run, if you enter 3 equal numbers, then you get all 3 values are equal. And in the third run, you get that none of them or no 2 equal values. So the question, enter 3 integers, tell us whether they are all equal or only 2 are equal or none of them is equal to any other value. So the user needs to enter 3 integers and then we do the check. Okay. So in our program, we need 3 integers be input from the user. Let's call them x equals integer input 10, enter first value. This is how we read integer from the user. And then we do y and z. Here we do y and z. And here we say second. Then we say what? Third. Come on. So now we have 3 values received from the user. How can you check if all are equal? You can say if, for example, x is equal to y and x is equal to z and z is equal to y. If all the 3 are true, then what? X is equal to y and y is equal to z and z is equal to y. Is that true? Let's test it. Print all 3 values are equal. It's a good idea to stop here and test your code. It's a good idea to stop here and test your code. I run the code now. My output will be, I enter 4, 5, 6. No output because my if was false. I will run again the code. Run. I'll enter 3 values, 10, 10, and 10. All 3 values are equal. Let us see if our condition is good. Let me enter 10, 10, and 15. I get no output. So when I entered 3 equal numbers, I get all 3 are equal. Then we need to do another question, which is to check if only 2 are equal. So here we can say what? If x is equal to y, for example, and x is equal to z. Is this true? Is it going to give us right results or wrong results? What do you think? The second if x is equal to y, or I can write or z is equal to y, x. Yani, if any one of these things, if any one of these 2 are true, I can say here, and here we can say z is equal to x. If one of them is true, okay, then the expression will be true, right? Let's see. put another expression, or y is equal to x, y is equal to z, or what? Do we have a third option? In the first one, we check if x is equal to y or z is equal to x. Then in the third option, we will see if, I'll do it without or. If you're not sure, you can just go ahead and test. Print two values are equal. Let's see if we get an output. So here we have, I think, extra bracket. These are two different ifs, ya shabab, not one if. Let me put 10, 10, and 20, 0. So it didn't work. X and Y were equal, right? So do I have to check here? Or Z is equal, no need for or here. If X is equal to Y, or X is equal to Z, this is very easy now, or Y is equal to Z. Do you agree now? If any one of them is true, then two values are equal. It's either X and Y are equal, or X and Z, or Y and Z. Let's try it with the three different combinations. In the first time, I'll make X and Y equal. 10, 10, 5. Two values are equal. In the second run, I'll make the first and last equal. 10, 5, 10. Two values are equal. The third time, I'll make the third and the second and third equal. 4, 10, 10. Perfect. So we get the right output. Now I can go and make this elif. So it will only come here if the first one is false. Else the third option that none of the three values all are different. I can output a different message here. All three values are different. Or you entered three different values. Let's clear everything now and run. If I run now, I'll do 10, 7, 7. Two values are equal. Run again. I'll do 10, 1, 1. Two are equal. I can also clear now. And I'll enter three different numbers now. 10, 4, and 5. All three values are equal. So we checked that. In the first one, are they all equal? In the second one, if any two are equal, and if none of the previous two expressions are true, then we go to the trailing else, which is the last option. In this program, we are asked to enter our value in Celsius temperature. Then we need to show the value in one of three possible temperature systems. Celsius, Fahrenheit, Kelvin, and Rankine. You see the formulas, how to convert from Celsius to Kelvin and to Rankine. However, what's important here is the way we need the program to run. You will enter the Celsius temperature first, then ask the user to enter either F or K or R. If the user enters F, then you convert the Celsius to Fahrenheit. If he enters K, then you convert it to Kelvin. If he enters R, you convert it to Rankine. If he enters a wrong choice, like here, as you see in run number 3, if he enters X, you tell him invalid choice because you are expecting either F or K or R. One more thing, your program should accommodate both caps and small case letters. If the user enters capital F or small f, it should work. You should take care of these two things. So our input will be one value for Celsius. Our output will be one of three values, either Fahrenheit, Kelvin, or Rankine. Okay. So our input will be in Celsius, and this should be a float. We cannot do it an integer because temperature can be in any value. So I'll say here Celsius is equal to float input and enter temperature in Celsius. And we have it. Now I need to show a message to the user, similar to the comments you see in lines 2, 3, and 4. The message, I need to tell him to enter F or K or R. So I can do print here. Okay. I just use a single quote. I try to copy the messages from here. Okay. Print F for Fahrenheit and another print, single quote. Try to copy the message here for Kelvin. And finally, I will tell him to print R for Rankine. So now I need to get the choice from the user. The user is going to do some input. The user is going to input. Here I can say choice is equal to input, enter your choice. So now the user is going to enter either F or K or R. Let's say we will check for F first. So our check system will be very simple here, our expression. If choice is equal F, then Fahrenheit temperature is equal to 1.8 times Celsius plus 32. We are done here. I can just print what? I can print Celsius, and print the temperature. Then I can say in Celsius is equal to, then I can say F in Fahrenheit. So my output will be showing him the temperature he entered in Celsius, then the output in Fahrenheit. Else if, elif. Now I'm going to do the same thing again. I'm going to do copy paste, by the way. Okay. Now choice is equal to what? K, Kelvin. Then K is equal to 273.15, I believe, 273.15 plus Celsius. And this semicolon is definitely wrong. Inherited it from other languages. Okay, so now I can say K, the value in Kelvin. Okay. Good. The third choice, I'm not going to say the last because maybe the user is going to input something wrong. Else if choice is equal to R, then I would say Rankine is equal to, I need to do this and all of this multiplied by 1.8. So this is the Rankine. So I'll say here R, and here I would say Rankine. If it's not A or not, sorry, if it's not F or K or R, then it is something else and it's a wrong choice. So the last else will be here, print wrong choice entered. If I want to test this program, let's see here, I will run and see what output I will get. Clear first, okay, run. Enter temperature in Celsius, I entered 44.0 or 0.9. Enter what temperature? I entered K. 45, whatever in Kelvin is equal to that much in Celsius is equal to that much in Kelvin. Let me run it another time. I would say here now 18. I want to select Fahrenheit. Good. I will run it another time, but please pay attention. Now I'll enter 44, but I'll enter capital R. As you see, capital R is not one of the choices because, you know, capital R is not as small r. So your output is equal to wrong choice. So if you want to get both of them accommodated, you can say or choice equal capital F. And I would do this for all of them. You would do this more professionally later when you learn. This is capital K. And here I need capital R. So now I believe I did something wrong somewhere here. Okay, good. And here also. So now if the user enters small f or caps F, it will go here. Otherwise, it will go here, whether capital or small k. Finally, if it's small r or caps R, would go here. Else, it means a wrong choice. And this time we are confident it's definitely a wrong choice. It's not only case problem. So now we enter this value, 44.4. I entered capital K. I get it in Kelvin. I run it another time. I enter any number here. I enter capital F. I get it in Fahrenheit. If I run it with a wrong choice like now, 44, and entered M, wrong choice entered. So this way we were able to accept input in Celsius as a float. Then depending on the choice entered by a user, which is a string, we checked which choice he selected, and we took care of the case difference, if it's a small or caps case, and we took care also of any invalid value. The third question here is how to find the maximum of only 3 integers, and the integers are unequal, maximum and minimum. If the number of values is huge, you need to use loops. But here the question is specific, only 3 integers using if and if else. So the values must be unequal. We need to find maximum value, minimum value, average. Average is the easiest. If you know how to find maximum, then it's the same thing, how to do minimum, just change the operator. And there are actually more than 2 to 3 ways to solve this problem. In the beginning, I expect you to enter 3 values. I can call them A, integer, input, enter, and integer. Okay, and then we're going to go and do it for B and C. So now I have 3 values here, B and C. We need to make sure that they are unequal. We need to make sure that none of them is equal to the other before we start working. But sometimes, if you try to do this validation before, you could make your code more complicated. It's up to you how you make it. I will do it first without validation, okay? So now here, I can say if, this is one way of solving it. If A is greater than B and A is greater than C, what does this mean? A is greater than A and C. is greater, sorry, than B and C. Then maximum is equal to A. I can say here sys out, oh, sorry, I can say here print, okay, print A, comma, is max. Okay. However, I can say elif is greater than A and B is greater than C. Then which one is max? Now B is the max. I can do print, but now I say B is max. I'm not going to say else C is max, but I will check now. I can do another elif here. I can say if C is greater than A and C is greater than B, then which one is max? And C is greater than A. Here I need to change this to B, right? Now C is max. If A is greater than A or B, then A is max. Otherwise, if B is greater than A and B is greater than C, then B is max. Otherwise, if C is greater than A and C is greater than B, here I need to change this to B, then C is max. Otherwise, it means two values are equal. Otherwise, if none of the three choices are true, if none of them, it means what? Two values are equal. Here I can do else, for example, rent, equal values entered. Equal values entered. I will try my first test here of this code. I will run, enter an integer, 4, 5, 6. 6 is max. I will run this code again. Run 10, 999 and 1 or 2. 999 is max. And now I'll enter 10 and 10 and 88. 88 is max. Okay. Yeah, right. If let me see. 88 is larger than them. Then my logic was wrong. 88 is larger than A and B. So my logic is wrong. So what I could do, I know this logic is wrong. So I can go to the very beginning and check if they are equal or not equal. My logic was wrong only to eliminate invalid input, or if all are unequal. But if you enter two equal numbers, then this logic is going to work. So the largest here, and I would run this program again. I would enter what? 88, 88, and 10. I don't get an input. Why? Because my logic worked here. Because A was not greater than B, then this is false. B was not greater than A. Type C is greater than A? No. C is greater than B? No. So the logic I selected in the beginning was wrong. So now what I can do here, I would say if A is equal to B, or B is equal to C, or exactly the same way we did before in another example, or A is equal to C. Now what I can say in the beginning, Brent equal, I don't want to work with this one. Equal values entered. My condition was ask the user to enter 3 unequal values. Now we can go to this elif. So I am pretty sure this one should work if any two values are equal. The remaining ones should work if the values are fine. Let us clear now, run this code here. I will enter 10 and 10 and 999. Equal values entered. I will run again, enter 10, 99, 99, equal values entered. And now I'll enter 3 values equal values entered. So you see that we made sure that our logic is working fine. Now I'll enter 888 and 8. 888 is max. Then I can go to 9 and 9 and 999. This code is going to tell me 2 equal values. Does that make sense? So next part is how to find the minimum. The minimum is going to be the same thing. The minimum is going to be the same thing. I will start a new if. Okay. I will start a new if. I can say here, I'll just do what here? I'll just make this what? Minimum. Less. I'll make it just less. If you do this and change the word max to minimum, and everything will be fine. Just change this. And here I would say minimum, minimum, minimum. Let's make sure it's running fine. I will enter 3 digits now. 9, 999, and 999. So 999 is max, 9 is minimum. I will run this code in many times in many different values to make sure it's all running fine. Then I will enter 10, 100, and 2. Fine, good results. Now I'll enter a big number at the beginning, then a smaller one, then the smallest at the last. I get right results. Of course, the average is very simple. I would do it here. I can say sum is equal to A plus B plus C. And if you want, AVG is equal to sum divided by 3. And that's it. Now I can just need to print average, print AVG, or I can just put a good average is equal to AVG, and that's it. I will run this one final time and then solve it in a different way. Okay, I enter 10, 99, and 4. Average is 37, 99 is max, 4 is minimum. I will save this code and try to do the same thing now in another way. Without using this complicated code, I will write my new code here. I'll keep the same code here, but I'll show you how I would save it. I would solve it. Okay, we are done with the sum and average. That's fine. And this logic is fine. Right. If all of them, if A is greater than B or C, we know what to do. We just print a message and this is quit. Now let me show you another logic. I will say max is equal to A. I'll say the first one is the largest. I would say here, the first one is the largest. Then I will check if the second one is larger. If B is greater than max, then max is equal to B. Then I'll check if C is greater than max, then max is equal to C. By the way, we are done. We know now which one is the max. I can say now max is the largest value. If you want to think about this, we take the first value and store it in another variable, which is max here. Next, we compare B to max. Let us say A was 10, so max is 10, but B is 15. So B is greater than max. So now max will be switched to the value of B. Max is equal to 15. Then if C is 3, C is compared to max, false. So the value of max will be 15. I will remove the remaining parts of the code and let's go and test this code in the beginning here. We need to save it. Okay, PS2 3 1, which is the second solution for problem number 3 in the problem solving session 2. I enter 3 values now. And let's see, 6, 7, 8 is the largest. Very simple code, very useful, and it's also going to be useful in loops. Now 999, 8, and 67, I get the right result. I can right away, guys, I can right away copy all of this and use the same logic for what? Minimum. I will say the minimum is equal to the first one. However, if B is less than the minimum, then the minimum is equal to B. If C is less than the current minimum, I keep change the minimum depending on which one is the lowest value. And minimum is equal to C. And finally, I print the minimum, not necessarily A or B or C, the value that I stored in minimum. So now my code is expected to output the maximum and minimum, but the comparison is much simpler than what we did in the first version. So let me run this now. I entered 999, 89, and 678. Largest value is 999. 678 is a smaller. I can here also print average. Okay, to make our solution complete, I can print average AVG. Okay, now I showed you here how to do it using complex if statement and using relational operators, and if A is greater than B and A is greater than C, then A is the largest. And here I showed you how to use temporary value where you store the minimum. You consider always the first one to be the lowest. Then if the second one is lower than the first one, you switch the values. You check the third one. This logic is going to be later used with you and in loops. When you compare millions of values, this is the one that you need to use. The first logic you saw in this example is valid when you only have 2 to 3 numbers. But when you have thousands or millions of values, you must use some kind of comparison like this. Now, I am not supposed to do any work unless what? Unless all these values are unequal. The question says, assume the values are unequal. So let's see how I'm going to do this. I would say if A is equal B, or B is equal C, or C is equal, or C is equal, that's it, or C is equal A. Okay, if this is true, print equal values entered. Equal values entered. However, all the remaining work I need to do only if this is false. That's fine. I can come here, type else, then put all this work. I can select it and press tab. Now all this work is inside the else part of my code. All this code now will be executed only if this condition is false, because your code will come to else. If you look at the code now, if we close this, if you look at the code here, if this is true, then you just print error message. Otherwise, all the code in the remaining blocks will be executed. Let's do one final run here. Enter an integer, 188, 987, and 33. You get the average. And if we clear this, we run it again with equal values 10 and 10 and 888, equal values entered. So the program will quit from line 5. If the statement in line 4 is true, it will quit on line 5. If it's false, then you come to the else part where you have everything you want. A company decided to give bonus to employees based on their years of service. If it's more than 10 years, then they get 10% of their salary. Greater than 6, but less than 10, less than or equal. Here you need to be precise. So this one is if it's only greater than 10 years. So 10 years sharp will be here. And if it's less than 6 years, it's going to be 5%. The program should ask the user to enter salary and how many years he was in service. I'll copy paste this into our code and go ahead and so we are expected first to ask the user to enter how many years of service and then the salary. The years of service, I believe in this example could be integer maybe. Integer or enter years here. I would say years equals integer. How many years you have been with us. And next I'm going to ask him about salary, and that's a straightforward program, salary, and that's going to be float input, and I believe we forgot input here, and that's it. Now it should work, and we do the same thing here, input, what's your exact salary. That's it. Then we have the data. Okay. Now we need to see how much money should be given as a bonus to each of them depending on the year of service. So the first one is very simple. If what? Years. If years is greater than 10. Greater than, not greater than or equal. Then what's going to happen? I would say bonus is equal to what? Salary times what? 0.1. Else, if years greater than or equal to 6 and years less than or equal to 10. So this way, 6 years, exactly, 6 years exactly, elif. You know, I'm coming from different languages, right? elif here, if it's more, 6 or more up to 10 exactly, then we would say bonus is equal to salary times 0.08. And finally, we'd say else or elif, years less than 6, then what to do? Bonus is equal to 0.005 times salary. Finally, I can print the value of the salary. I would say print your bonus amount. Bonus amount is equal to, and then say bonus. I will do this first without any validation here. Enter how many years you have been with us, 8, and the salary is 6,000. So I believe I get 8%. Always try to put a space after this one, after the input message. I will run it again with clear values. I have been like 15 years and my salary is 10,000. So now it's 10% of the 10,000 is 1. And as usual, if you want your program to be complete, try to make some kind of validation. Like here, for example, if I enter -5, what's going to happen? It will go to the last else, right? So it's a wrong way of calculating things because there was a wrong in the input. So what we would do here, if salary, in one statement, if salary is less than 0 or years less than 0, then I would say what? Print print negative values entered, exiting. Okay, of course, now I need to change this to elif. So now my code takes care of any invalid values even. So if I enter here -5, I get negative values entered. Let us make sure here. Okay, and there is a problem here. You see that this print amount will be printed in all cases, right? Yani the last print here, it's try to print it even when the values are wrong. So now I can do one thing here. I can put this inside else and put everything here. Sorry, I made a mistake. Okay, sorry. I can take care of this here inside. So now we go only to the second else if the first one is false. I know people would hate this way. So now see what I'm going to do. I'm going to do the opposite. I'm going to say if salary is greater than or equal to 0, and people hate to make this thing in the beginning, and years are greater than 0, salary is greater than 0. If it is like this, if it's like this, go ahead and do all of this. So you go inside here, only if these things are great, else print negative. It's the same thing, but we made that thing first. Negative values entered. I'll see what error I did here. Entered, exiting. And let's see here if, oh, it's indentation thing. Now look at it now. If this is true, I do these things. Otherwise, I will go and tell you this message. So if you enter -5, I will quit all this logic. I think people prefer to do this first to make sure the data is valid, then do this first. Otherwise, they do that. Let me just run this with negative value, -8 and 10, negative values entered, 10 and -5, negative values entered. So your code now takes care of validation in both ways. Now I'll enter how many years you have been with us, 10. What's your salary? 888. So you get this much. So this way we solved the problem of validation. You could do it in many other ways. If else, nested if, they all work. Mix of both also is good. This question is about electricity bill. Write a program to calculate the electricity bill, accept number of units from the user, like kilowatts consumed or something, according to the following criteria: units and price. First 100 units are free. And if you consume only 50 units, then no charge, 0. The next 100, and this is important here, the next 100, yani from 100 to 200 or from 101 to 200, you pay 5 riyals per unit. After 200, only after 200, you pay 10 riyals per unit. I want you to understand something important here. If you consume 300, the first 100, no payment. Then I charge you 5 riyals per unit from 101 to 200. Then anything after 200, I charge you 10 riyals per unit. It's not one category. It's not one category. So if you consume 400, 0 for the first 100, you get it. Then between 100 and 200, only 5 riyals per unit. Between 200 and 500, you're going to pay 10 riyals per unit. So this is our category here, and we will write it in code. Now here we try to write our programs. The user is going to enter the number of units, which is clearly going to be an integer. Then we calculate the charge or the bill amount depending on the number of units. So I'll say units equal integer input how many units consumed. Okay, so now I know how many units, and now I need to say bill amount is equal to 0 in the beginning. If units less than or equal 100, okay, then bill amount is what? Is still 0, صح? Right? Is still 0 if units is less than 100. Right. Now I'm going to use not elif. I'm going to use another if, because we said you're going to pay for all of them. So it's not if else. I'm going to use another if. You could solve it with many different ways, but make sure your logic is right. So now, if units less than or equal to 200, now if it's equal to 150, for example, you only need to pay for 50. You only need to pay for 50 because the first 100 were free. The first 100 were free. So I can say now, bill amount is equal to or plus equal to units minus 100 times 10 times 5. Now I said bill amount is equal units minus 100, because if you consumed 150, already the first 100 are free. So I will deduct 100 from your 150. So 50 will remain, so you will pay only for 50 units. I'll go for another if now. If. Now, خلاص, it's the last if now. I can say if units is greater than 200, I'm not going to say greater than or equal because this one took care of the equal sign. Now, if it's greater than 200, you must have paid something here. And here the first 100 were free. So now let me show you how I would do it. Bill amount is plus equal units minus 200. Anything before 200 you already paid either here or here. If you consume 350, you are free. You get free for the first 100. Then for the next 100, you paid already 5 reals per unit. Then only from 350 to 200, you need only to pay 150 in this price. Now I know how much is the bill unit. So I can say here print bill amount is, I can say bill amount is equal to comma bill amount. Let's just try this first, make sure it's working fine. And let's try it first. I will enter, for example, 150. Run. 150. Perfect. Because 5 reals for those between 100 and 200. The first 50 are free. Let me just run it with 75. 75, your bill amount is 0. If units is less than, okay. Here we made a mistake. Huge mistake even. 75 is less than 200. 75 is less than 200. So it went here and here. Both were true. These are two separate ifs. So here I can say if units greater than 100 and units less than 200. So now if it's only greater than, otherwise don't come here. Let me run it now with the same value now. I'll enter 75, 0, because the second one was false. Now let me just clear again this thing and run it with a larger value. We'll make it simple to calculate. 300. 300, the first 100 will be free. The second 100 you will pay 5 riyals for each unit, which is 500. The third category, let's say between 200 and 300, you'll pay 200 riyals. So let's calculate this. It's 1,000. So 300, okay. Wait a minute, did we go here? Okay, there was something wrong now. Even my choice did not go inside. It did not go inside because here it did not go inside. Why it did not go inside? Because 1,000 is not considered true here. 1,000 is not considered true here. So how would you do this? I can do it in many different ways. I can say, for example, if it's greater than 200, then bill amount, I can calculate it here. Plus equal, for example, 100 times 5. This is for the first, the second 100. And here I take care of what? Of the, I add the 500 between 100 and 200 because the rate is 5. Let me run this and see how my output is going to be. 300. It's 1,500, correct. Because between 1 and 200 you pay 5 riyals each. Then you pay 10 riyals each for anything more than that. Let us make sure it works fine for all types of input. For example, 150, 250, good. 250 because you have 50 extra units for 5 riyals each. Let's run it one more time with only 70. You get 0. So I will run it one final time here. If you play, I will run it one final time. I will say 400. 400. You pay 10 riyals from 200 to 400 and 5 riyals between 100. So the number is fine. You can play with these conditions. I cannot force one logic on you. You can select any number, any way. You can start from the largest or start from the lowest. Or you can check for two things. Here you can say if units is greater than 0 and less than 100, then if it's less than that, do this. You can, let me tell you one thing. You can also do elif here. You can, remove this. If you do elif here and remove this, then it will go either here or there. It's up to you, but you need to study the logic. You need to see what are the possible choices you have. Which one is better? Which one is easier? Which one more clear? So now I'll run it one final time with 150. It should be 250, and hopefully this is our final solution. Now, if you want to make any kind of validation, if units less than 0, then you have an error. Here I can say if units greater than 0. Why I'm saying this? If units greater than 0, I will take all of this and press tab. Now they are all else. Okay, you know what we're going to do now. Print invalid value. Values entered. Entered. So if you enter invalid value here, I'll make 150. Excellent. I'll enter a negative value now, -5, invalid values entered. In this example, we're going to calculate the amount of tax an employee has to pay. It depends on two things, the salary and the number of kids. If you look at the table here, if the salary is more than 15,000, it doesn't matter how many kids he's got. He's going to pay 25%. If it's between 10,000 and 15 with 0 kids, he's going to pay also 25%. But if he's in the same range with kids less than 2, he will pay less than or equal to 2, he will pay 20%. Salaries, again, between 10,000 and 15,000, they have 3 different categories. 0 kids, they pay 25%. Less than or equal to 2 kids, they pay 20%. And greater than, or less than 2 kids, less than or equal to 2 kids, they pay, let's make this 10% now. 2 or more kids, I think one was wrong, sorry. I will come here now. I see here 0 kids, less than 2 kids, greater than 2 kids, they pay only 15%. Yeah, that was right. Now between 5,000 and 10,000, less than 2 kids, they pay 15%. More than 2 kids, they pay 10%. If it's less than 5,000, it doesn't matter how many kids, they pay 5%. So what the employee is going to enter is the current salary and then the number of kids. We will revisit this table again to see if we are doing things right. The first 2 things is like number of kids and salary must be entered. Now we try to find how much tax should be paid by the employee. First, we need to ask him about the number of kids. That's definitely going to be integer. So we'd say kids is equal to integer input. How many kids? And then we just need to change this. Next one is going to be salary, and salary most probably is going to be something with fractions, so it's going to be like float. Then we say salary is equal to float input. Okay, what is your salary? Now we have the salary. If we look at the first category, any employee more than 25,000 or 15,000, it doesn't matter how much the kids are. So I can start from 8th. Salary is greater than 15,000, then tax is equal to 25%, 0.25 times salary. We are done with the first one because he's going to pay 25%. It doesn't matter how many kids are there. Next, if his salary is greater than or equal to 10,000 and salary less than or equal to 15,000, and one more thing we need to check now. For the second employee, second grade here, we need to see those with no kids between 15,000 and no kids. Here I could say, and still 3 things must be true. And kids equal 0. If the employee falls in this category, then again he needs to pay the same tax. And by the way, this should be elif because it's going to be either or. So now if he takes more than 10 and less than 15 and still with 0 kids, then he's going to pay 25%. The third category here, if he takes that much salary and but kids are greater than 2, are less than 2, يعني not 0, greater than 0 but less than 2. So here I would go and say I could copy the same one, but I need to pay attention to okay, and kids are less than 2. Kids less than 2. Here 0 is not needed to check for 0, because if it's 0 it would come here. Yani if he takes 12,000 and 0 kids, it will be taken care of here. But 1 kid, One kid, let us see the question, less than or equal. So this must be less than or equal. So again, this type of people, they need to pay only 20%. Let us make sure we did the right taxation here, 20%. Now, people in the same category with more than two kids, they're going to be only 15%. So I'm going to, again, can copy the same code. I'm just going to change the kids. Here I can say kids greater than 2. Greater than 2 means going to be 3. And because kids in an integer, no one's going to have 2.5 kids. So we are done with all those 15,000. Now let's go to greater than 5 and less than 10. Less than 2 kids, 15%. I can copy paste there. Here, I can say here, next category, greater than 5,000, and salary less than, not less than or equal, according to the table, less than 10,000, and kids less than or equal to 2. So if a guy with 1 kid or 2 kids between 7,000, he's going to pay, according to this table, he's going to pay 15%. So this guy is going to pay only 15%. And I believe this one should be also 15% according to the table. Next, we have people from the same category here. Sorry. Here, if they have more than 2 kids, if they are more than 2 kids, it will come here and it will pay only what? 10%. Finally, if it's less than 5,000, so we could say here, else I can also, if salary is greater than or equal to 0 and salary less than 5,000, it doesn't matter how many kids you have, so your tax will be 0. 0. Finally, you can just come out of the if and say net salary is equal to salary minus tax. This is how much you pay. This is your net salary. So I can print all of them, print salary, and I'll type salary. Then I could say tax, and then tax, and finally net salary, and comma, net salary. I will run this code, for example, first time with very little number, like how many kids? 2, but the salary is 1,000 only. This guy is not supposed to pay any taxes. Excellent. Salary is 10,000 or 1,000, and tax is 0. Net salary is 0. Let's see another category. I will run it now with 20,000. He's got 2 kids, but his salary is 25,000. It's more than, it's the highest one, which is, let me make it even number so we can say it's right, 20,000. 20,000, he pays 5,000 tax because it's 25%. I will run it again with new values. I'll make it 0 kids with 12,000. This guy is also going to pay 25%. And if I make it with 1 kid, we're going to get 1 kid with the same salary. He pays 12% or 15%. I'll make it with the same salary, but with 3 or 4 kids, same salary. We see each one is getting different taxes depending on how many kids he's got. I will go finally to test someone between like 3 kids and the salary is 6,000. And here we say 10% because he's got 3 kids. If he's got less than 3, I will do the same thing now. I will say 0 kids and 6,000. So what we see now, the salary was only 15%. Is it? It was 10% here. Okay, yes, it was 10% because he's got 3 kids, and because here no kids, it was 15%, as you see here. 15% if kids are a greater here. Here, 10% if kids are more than 2, less than or equal to 2 is going to be 15%. Finally, we will see someone who doesn't pay taxes, and he's got 4 kids, but his salary is 2,000. So this category is not going to pay any taxes.